Okay, good afternoon once again. We get started with the time value of money concept. Now, I want to ask quickly, if I were to give you two options, option one, I give you 1 million naira now, or option two, I want to give you the same 1 million naira in, let's say, 10 years. Which would you prefer? The 1 million naira now or the 1 million naira in 10 years? Answers?
What? The 1 million naira now.
No.
The value.
Okay, so why will you prefer the 1 million naira now?
Because in the long run, for the 10 years, the worth of 1 million naira now is different from what it will worth in the future.
Okay, so are you saying the 1 million naira now will be worth more than in the future? Is that what you're saying?
Yes,
Okay, so why will it worth more?
because of exchange disparities, like the inconsistency and volatility of exchange rates.
Exchange rate. We are not exchanging, no. We are not doing dollar or to naira. It's just 1 million naira. We're
Not
not exchanging.
how will I put it?
Please talk. If you are raising your hand, please talk. I don't think. Okay.
The 1 million naira will be worth less in the future.
Come again. I didn't hear you.
Inflation. I said the 1 million naira will be worth less in the future, so I prefer giving it to me now.
Okay. Okay. Well, you are all right. Other options, other opinions. Please go right ahead.
Because of inflation.
Inflation.
Yes,
Okay. Any
exactly,
other
exactly.
contribution?
It's mostly because of inflation.
Okay. It's not mostly because of inflation.
Can I?
Please do.
Can I?
Go on.
Okay, so you want to give me 1 million naira now, or in
10
how
years.
many years? In 10 years. So if you're giving me now and 10 years, it's still the same 1 million naira you want to give me, right?
Exactly.
Okay, so it's the same. It's not like you're going to add anything for me. So I would rather take it now, invest it, and then in 10 years I would have been a multi-billionaire, I believe. Instead of
So that
waiting
means
for
it's
10
not the
years.
same. That means it's not the
It's not
same
the
then.
same. No, it's not
Yeah,
the same.
we are all right actually. So you are right. It is preferable you get the 10 million naira now than in 10 years time. Why? Opportunity. You can invest it somewhere and get returns, right? Two, inflation. Inflation will corrode the value of the 10 million naira before 10 years. All right. And then opportunity cost. You can use that money and tie it down with something rather than waiting till 10 years time. You can earn interest on it. We are all saying the same thing. Are we clear on that? Feedbacks?
Yes.
I'll be asking you if you are clear so that I'll
Yes.
be sure that I'm talking to you guys and that the network is still fine. So we go on. So when we now, okay, before we go on to the concept of time value of money, let me quickly take you back to secondary school, SS1. Or is it primary school? Now we have simple interest and compound interest. All right. So who can remind us of the formula for simple interest when you were about writing common entrance? Anybody? Nobody. Go on.
The principal over time.
It's been over 30 years. It's understandable. Don't worry. So
Principal times
Principal times time times 10.
I'm not hearing you guys clearly, but I'll just try. So let me draw. Yeah. So simple interest, permit me to write I. I hope you can still see my screen.
Yes.
Is equal to PRT. All right. PRT over 100. P being your principal, R is the rate, and T is the time. Please open your CIS manual because, as I said, I'll be dwelling more on this page. Okay, so we go. So yeah, let's take this example quickly. Can I get a volunteer reader? Somebody to get example number 1 for us quickly. Anybody?
Mark and Kate savings accounts. Can you hear me, please?
Yes, it's manageable.
Oh, Mark and Kate opened savings, both opened savings accounts with a starting balance of 1 million naira on the same day. Max Bank is paying him using compounded interest, but Kate's Bank is paying her using simple interest. Both Mark and Kate are receiving an interest rate of 8% annually. Who will have the larger balance in 5 years?
Okay, so who will have the larger balance in 5 years? So let's hazard a guess. Who do you think will have a larger balance? Is it Mark or Kate?
The one with the compound interest.
Compound interest.
Hi, this one like I'm straining my ears to hear you guys. What's going on?
We said the one with the compound interest.
Okay, the one with the compound interest. No wonder. Okay, so why is it the one with the compound interest? Because compound interest means that for each successive year, the interest gained will be rechanneled back into the investment and it will also earn its own interest. Are we clear on that, everyone?
Yes, sir.
So if that's the case, then let's delve right into it. So let's start with who is taking simple interest? Kate. So let's go with Kate. How much is the sum? You know, in primary school, we're taught to always list out our values. 1 million. What's the rate? 8%. And what's the time? 5 years. So our simple interest in this case will be what? 1 million times, let me just put this as 0.08. This is what I need you to be familiar with, times 5. I'm not using over 100 because I've already divided 8% by 100 here. I hope this is clear, please. So going on, input this in your calculator. Tell me, what do you get? Please, if you have anything to say, go right ahead and tell me, please.
Excuse me, sir. Emanuela, can you share the material in the group? I can't find it.
Okay, so have you joined the level 1 group? We have shared it on level 1 group.
No, I've not joined the.
Okay, just send me hi so that I can add you.
So
No,
why we
but
say, okay, go on. Give me the answer.
sorry, sir. The answer is 400,000 plus. Emanuela, please just share the link so that everyone, so that we don't just keep messaging, so that we don't disturb.
Okay, no problem.
So here we see that the simple interest for Kate is 400,000. What this means is that at the end of the 5-year period, is what we call amount. Amount is simply the principal plus the interest. So what is the amount? I'm tempted to say, Manuela, what's the amount Kate is going to receive at the end of the 5-year period? That will be the initial principal, 1 million, plus the interest, 400,000, and that gives us a sum total of how much? 1,400 or 1.4 million. All right, so that is for, who is this? Kate. All right, so we move on to the next person, who is who? Mark. So for compound interest, what is the formula? The formula for compound interest, we go amount. We go all the way to the amount for compound interest is principal into 1 plus r raised to power n. All right, now this formula is the basis of financial mathematics. You must understand this formula very well. Future value, present value, annuity, they are all offshoots of this formula. So what does this mean? Again, how much will who is this person now, Mark, get at the end of his 5-year period? You know A for what it is, you know your R to be the rate, and you know your N. N now is what we use to replace T here, the number of periods. So we go again, principal 1 million into 1 plus. Now, what is the rate again? 8%. 8% is expressed as 0.08. Please take note of this and don't confuse it with 0.8, which is the same thing as 80%. This is really very important, please. Then raised to the power of what? How many years? 5. So altogether, everything here becomes 1.08. So get your calculator and type 1 million into 1.08 raised to the power of 5. What do you get? Are you typing? Are you typing? I want an answer.
So the answer I have here is 1,469,328.
1,469,328.03. Now, Mark and Kate, who has a greater sum at the end of the period?
Mark.
Mark, and we know why. All right, because of the fact that his interest each year, when plowed back, gains further interest as well. So that's why compound interest will give you more funds. So that's what we have just done here. All right, so I'm going to leave you with the bulk of the text. You can always just read through them so as to save time, but the core concept is what we are going to focus on, which we are doing here already. So that is also example number 2. Somebody
Sir,
wants
please hold on.
Sorry?
Sir, I was going to ask a question.
Okay.
Please, the rate is 8% now, but you're dividing it by 100. I want to ask why you are doing that.
Where exactly?
This 0.08 is for rates now, and in the two equations you divided it by 100. Abi?
Okay, so let me go over that again. Ideally, for simple interest, it is principal times rate times time. Now, this your rate is the percentage beat, okay, over 100.
Yes.
Now, this rate is actually what carries this 100
okay.
on its own. All right, so oftentimes, we said 8%. That 8% there is 8 over 100.
Okay.
Now, but as you go further in financial mathematics, we usually do not express it this way. We express it as a decimal so as to save time. So what is 8% as a decimal? 8 is a whole number. The point is here. How many zeros has 100? 2. So you are moving to the left 2 times. 1, 2. So it becomes point here, 0 in the front, and 0 in the middle. That's 0.08. Are you with me?
Yes, sir.
So if it had been... Go on.
Yes, sir. In the compound interest equation, there is no over 100 there. But do we just assume that the rate is always divided by 100?
When you say rate, it's expressed as a percentage and it is always over 100.
Okay.
Yeah. So you can even see that ideally, I'm not even supposed to have put this here at this level. I'll just write R equals to PRT. I think that was what was done in the CIS manual. Yeah, look at it here.
Okay.
Can you see that there's no over 100 here?
Yes.
So that's how it works. But then again, the most important thing you need to focus on is on this conversion from fractions to decimals. In this case, this would be 80 over 100. Your point is here, 2 decimals, 1, 2. That would be 0.8. Are we clear on this?
Yes, very clear.
Don't go and do 1 decimal place where you ought to do 2 and vice versa. So that's a point. And I guess you're done with that. So let's move on. Example number 2 quickly. Who is reading? The person who asked the question. Could you please help us with example number 2? Just read out loud, please.
What compound rate of interest will be required to produce 5 million after 5 years with an investment of 4 million?
Good. Now, do you remember what is called change of subject of formula from primary 6, GSS 3, and SS3? You remember, right? It's like I'm taking you guys memory lane this afternoon.
Yes, sir. Yes, sir.
Oh, good. So let's see. Let's do a bit of brain juggling on that. So if y is equal to bx divided by k, who can make k the subject of the formula here?
K
So we divide both sides by k.
Divide both sides.
No. We cross multiply.
Cross multiply.
He said, don't worry, I understand. It's been over 40 years you left secondary school, so it's
K
understandable.
is equal to bx over 1.
Come again.
K is equal to y over bx, right?
No,
that's not what you said, though.
Wait. Bx equals to
ky now. Ky
Dx equals to yk.
equal to y.
YK. Is it YK? Who is saying YK there? DJ
It's
YK.
yk.
So it's actually KY, order of the alphabet, all right? So you are cross multiplying. So that means you can just put an over 1 here. K times Y will give you KY, and this will be BX, right? So what are we trying to make use of the formula again?
Divide both sides by y. So it will be k equals bx over y.
Divide those.
Now.
Okay. That was what you said at first. Then the second time I asked you, and you said something else entirely. Are we clear on this now?
Yeah.
Yes.
The other one that you didn't pick.
Come again.
Huh?
Are you talking to me? I assume not. All right, so we go. Quickly, what are the basic rules for change of Soweto formula? Because you're going to be using this a great deal in your financial maths. There are, let's say, 4 plus minus times divide.
Yes, close outside.
Please mute yourself if you are not talking to us.
Yes. Who's close?
Okay. Square. And let's say square root. Are you with me, guys? So if for now, every value in an equation has a sign, okay? So when plus has to come to the other side, it becomes a minus. When minus crosses over, it becomes a plus. Please mute yourself, please. When multiply comes over, it becomes a divide. When divide comes over, it becomes a multiply. When squared comes over, it becomes square root. And when square root comes over, it becomes squared. Are we clear with this, please?
Yes.
Now again, every value has its sign. The sign is in front of it. Okay, so the sign for B is a minus, negative B. The sign for C is a positive, plus C. The sign for A is a plus, but because it is coming first, the first value there, it is not written. But if it were to be a minus, you will find it there. So these are some basic ground rules we need to get sorted. Now, back to the initial question. What compound rate of interest will be required to produce 5 million after 5 years with an initial investment of 4 million? So what are the things we were given there? Again, you know our formula that the amount is principal into 1 plus r raised to power n. We were given the amount. What is the amount we were given? We want 5 million at the end of the whole show. Are we together? We were given the principal 4 million at the beginning of the whole show. Now, what else were we given? The number of years. What was it again? Remind me, somebody.
5 years.
5 years it is. Now, what is the interest rate that we need to apply on this principal over 5 years to get an amount of 5 million? So how do we need to proceed with this? Pick up your formula and make R the subject of the formula. So watch me as I do that, or guide me through. All right, let's go. Somebody? I'm trying to make R the subject of the formula. What do I do? Quickly.
Masado.
I think we're going to play the other side by hand, yes.
Come again?
Divide both sides by n.
You cannot divide by n. Why? Because n is not contact connected here. Hold on.
Divide by 1 plus r.
Hold on, guys. Look at each value here and see what connects them. What connects P to this bracket? What sign is here?
Plus.
The positive sign.
I didn't hear you.
Positive.
No. Okay, I don't mean by the side here. I know this is a positive P. What is between P and this bracket? And bracket means multiplication. So what is the inverse of multiplication? What's the opposite of multiplication? Division. So you are dividing both sides by P. Is that clear? Divide by P, divide by P. That takes this one off, and then you are left with A over P is equal to 1 plus r to the power of n. Is this clear?
Yes.
What are you making the sort of formula?
R.
You didn't follow us in the reading of the question. Look at the question. What compound rate of interest will be required? So that means we are making
For
R
yeah.
the
Looking
subject of
for
the formula. Are we good now?
Yes.
All right, so we have divided both sides by P. We have this left. What is the next thing that can go off N? How is N connected
N
here? N is a power. So what do we need to do?
square.
Uh-huh.
Square root both side by N.
But you cannot say
1
square
over
root.
n.
You find the nth
1,
root. Nth
1
root,
over
not
n.
square root. Yeah, 1 over n. So take both
1
of them
over
to the
N.
power of 1 over n. So I'm just going to multiply by 1 over n, the power of 1 over n. I hope this is clear. Who does not understand what I have done?
I don't.
All right. So this is it again. If you have y squared is equal to 36, what is y? The lady who said she doesn't understand, what is y? What number raised to the power of 2 gives you 36?
6.
6.
How is it 6? Because anything squared is that number by itself, right? So
Yeah.
another way to express that is just to see the square root of 36. Or it can be expressed as 36 raised to power 1 over 2. It's the same mindset or the same principle we used here. We had 1 over r raised to power n. Because we want to move this n to the other side, we multiply both sides by the power of 1 over n. Why? So that this n can take off this n, you'll be left with 1 here, and it would have been transferred over here. I hope that's clear now. If not, you can just do a bit of Google search on change of subject of formula after the class, and then you still watch the video again. If it's still not clear, you can reach out to me on WhatsApp. My number, I was the one who dropped QT class, so you can always reach out to me anytime. Are we clear on that?
Very clear. Thank you.
All right, so let's just move on. So at this point now, you have A over P raised to power 1 over N is equal to what? 1 plus R. Are you see how we are moving gradually? So now, remember we still want to make R the subject of the formula. So what do? We need to take this one to the other side. What's the sign for this 1? The invisible sign written here is what?
Plus.
Addition.
Plus sign.
1. So it means when this is coming over, it has to be a negative 1. So now, anytime you are moving something to the other side, please take note of this. Always write what is there initially first. So I'm going to say A over P raised to power 1 over N. Then plus 1 is coming over, it becomes minus 1 is equal to R. Are we clear with that? Talk to me,
Yes.
guys. Are we
Yes.
clear?
Yes.
Good. What this invariably means is that R is whatever our A is divided by P, raise it to the power of 1 over N, then you take away 1. Now that we have gotten a formula for R, we just need to slot in all those values we had initially from the question, and we should be fine. So we go. What is the amount? A 5 million.
5 million.
Divided by the principal 4. Okay, now I have chosen to ignore the zeros. Okay, because when you divide these zeros by zeros, you can still have 5 over 4. But if you want, you can write the 5 million as a whole. Are we in agreement, everyone?
Yes.
Yes.
Then raised to power 1 over what is our n? 5. Okay, then all of this minus 1. So get your calculator quickly and give it to me. What is 5 divided by 4 first and foremost? Five divided by 4?
1.25.
1.25. Raise that to the power of 1 over 5. I hope you can do that on your calculator.
How can we do that?
1.04.
You cannot get 0.2. 1.0456. Always go minimum 4 decimal places first and foremost.
Okay.
Then
How
minus
did they input
1.
it in the calculator?
Come again?
How did they input the 1 over 5 in the calculator?
I don't have my calculator here.
Okay, so if your calculator is with you, let me take it again so that we can go through it.
Yes, just continue.
So first you divide 5 divided by 4, that's 1.25. So you now go to x square on your calculator. Can you find S square in your calculator?
Is it the Casio, right? Which
Yeah, the
part?
Casio one.
Yeah,
X
okay.
square. Have you seen X square? Are you with me?
Yes, I am.
So
Okay.
1.25 after you have pressed that X square is going to give you 2 on the top of your 1.25, right?
Yes,
So
yes.
you would see the replay button that has 4 sides. Then you go to the left, click the left
Yes.
button on that replay. After clicking that,
Yes.
now go to what do I even call this? Under calculate, there's 2 boxes on top of each other. It is directly under calculate.
Okay.
So when you press that, then you enter 1, then you come to replay again, press the button down button and put 5.
Okay.
This your explanation seems a bit too complex for me.
I know, but
But anyway, let's just move on for now. You get easier ways as you go. I hope that's clear now.
Yes, thank you. Yes.
All right, so eventually, when you take away 1 from that, you should get 0.0456. Are we clear, everyone? Are we clear? Are we together?
yes.
Yes.
All right, so this is your answer, but expressed as a percentage means you multiply by 100. And to do that, just move your points twice to the right. 1, 2. That gives you 4.56%. I hope this is clear. So here you have it. Any questions? All right. There shouldn't be, because this is just basics. This is we going back to secondary school. We've not even started what we should. Okay. Are we clear up until now, everybody? Who does not understand? So there's nobody that doesn't understand. Okay, so let's move on then quickly. Somebody help us with example number 3 you are reading. So this is okay. So remember how I spoke about this compound interest formula being the basics for your mathematical something. This is it here, your financial maths. This is it here. We did say that amount is what? Principal into 1 plus r raised to power n. Amount is your future value, the amount you get at the end of the whole period. Then principal is your present value, the amount you're investing now. Every other thing still stays constant. Can you see it now? All right, so that's where we are headed here. Okay, who does not understand what I've just done here?
Again, please, again.
Okay, so you are familiar with the compound interest formula we used there, right?
Yes.
So all I'm doing now is I am replacing amount with future value and replacing principal with present value. Amount again is what you get at the end of the period. That is your principal plus the interest. So it makes sense to call the amount the future value. Then principal is the amount you are putting in now. It makes sense to call it the present value. This is the basic of financial mathematics. I hope that's clear now.
Yes, yes.
Please talk to me. I want to hear you.
Yes.
Okay, so having said that, we move on to this portion: present value, future value, and discount rate of a single cash flow or a lump sum. We take it gradually. Yeah, so we have this future value is this. Now, what will you, to make the present value the subject of the formula? What do you need to do? Who can tell me? I want to make this PV the subject of the formula. What do I need to do?
FV all over 1 plus R. The bracket
Divide both sides.
N. Great job.
Divide both sides
By what?
by 1 plus R power n.
Raised to power n. Okay, you just divide both sides by everything here. That gives you your PV. Okay, so how do you get your R? The R, remember we solved that earlier. That was we said it's A over P raised to power 1 over n minus 1. We can rephrase that to be future value, which is our A, divided by present value, which is our P, raised to power 1 over n, then minus 1. The minus 1 is whole. It's not minus 1 up here. Please take note of that. Are we clear on that, everyone? Who does not understand?
Again, please.
From where? Again, from where?
From this
From the future value, from the present value, or from the rate portion?
future value.
I didn't hear you.
From this computation you just made, A equals to PR.
And that's
P1
okay. Okay, so this is it again. Did you understand when we did this here?
Yes, yes.
So if you did understand, what I'm just doing again is I am replacing the amount with the future value and replacing the principal with the present value. So rate based on that is equal to future value divided by present value. Remember, future value was amount, present value was principal. So if you just replace that with those letters, you're fine. And then you have 1 to the power of n, then minus 1. That's just it. Can you see here? So I know the challenge is that change of subject of formula is giving us issues, and it's understandable. Some of you have left secondary school since 50 years ago, some 70 years ago. Is fine. So all you need to do is to just go on Google, type that in, watch a video, and then you bring yourself up to speed on that. Are you clear with that, with this, please?
Yes.
Hello?
Yes.
All right. So based on that, let's move on. Example number 3. Who's reading for us, please? Somebody help us quickly. Please read for us example number 3.
You are a lucky winner in your state's lottery of 5 million after taxes. You invest your winnings in a 5-year certificate of deposit at a local financial institution. The CD promises to pay 7% per year compounded annually. How much would you have at the end of 5 years if your money remains invested at 7%?
Okay,
Yeah.
so what are we looking for here based on what you have just said? Are we looking for present value? Are we looking for future value? Or we are trying to find the rate? By the way, we could
Future
also be
value.
asked to find the number of years and again change your subject of formula. All right, but let's just hold on for now. So you said, what was the answer to the question? What are we looking for here?
Future value.
Future value.
Future. How much would you have at the end of the 5 years? All right, so let's go into the question into our worksheet as we identify the things we need to work with. So that's example 3. What's our present value based on the question?
Present value is 5 million.
5 million. What else were we given? The number of years n to be 5, and then our rate is what? 7%. Okay, so you're asked to find the future value. Now, it's always nice you at least know this basic formula. This one here. Once you know this one, okay, this is the only formula I need you to learn. You can always move this underneath it to get your PV if you want to, or go on with your skills in change of operator formula and isolate R when you need to. You get to doing same for N in due course. Okay, so just learn this one formula and you should be fine. So for future value, I know that I am doing present value divided by 1 plus R raised to power N. Are we clear? Now, this could also be written as present value times 1 plus R raised to power minus N. Remember the laws of indices. Now, when you have, let's say A to the power of minus B, what it simply means is 1 over A to the power of B. You were taught this one in SS1 first term that year. Do you remember?
Inverse.
Aha. So, this is...
Homo.
Are you good to go? Is it too much? Okay, go.
No, it's not too much. Basically, this is the formula for future value, right?
Yes.
Okay.
Sorry,
Okay.
please, I have a question. How did you come up with the present value over the 1 plus R stuff?
Have you been with us all day? That's what we've been doing all day. See it here. Can you see this here?
Yes, but you wrote future value there.
And now, this is also future. Abi?
What's the future value formula?
Oh.
We already
Wait, so-
exactly. We already have a
Okay.
future value, which is PV bracket
Yeah.
1 plus
Yeah,
R.
my bad. Sorry. I'm trying to be faster than I should be. Sorry about that. That's my fault.
You're scaring me.
Sorry. So it should actually have been present value times 1 plus R raised to power n. Are we good?
Yes.
So there's no need for this here. Sorry about that. Okay. So this still holds, though it's not applicable for now. I hope this is clear now, everybody. All right. So now that this is clear, let's get the future value. What's the future value there for? Our future value is you have 5 million into 1 plus. How do I express this? 7%. How do I express it? Somebody tell me.
0.07.
0.07.
0.07.
What is it? Raised to power what?
5.
5.
Raised to power 5. 5 years. So this eventually turns out to be 1.07. So input that into your calculator. 5 million into 1.07 raised to the power of 5. And tell us what you get for your final answer future value.
Wait,
I'm waiting.
That's 7,012,000 and 7,012,758 naira.
Are we good, everyone? Who does not understand? Nobody. All right. So that means we are moving.
Sorry.
You're okay.
Please, why is there 1.07 underneath the?
No, I told you. I said this sums up to be. You get? I said this sums up to be. Then I drew the line. It's not supposed to be there.
Okay.
Are we clear now?
Yes. Yes.
Okay, so let's move on. Example 3 sorted out of the way you can see the answer here. And then example 4. Somebody else read for us quickly. Example 4.
Example 4. A paper company invests 4 million naira to clear a tract of land and plant some young pine trees. The trees will mature in 10 years, at which time the forest will have a market value of 8 million naira. What is the expected rate of return for the paper company's investments?
Great. Now we are not looking for future value. We are looking for the expected rate of return. Who can tell me the formula for expected rate of return? R is what?
R equals to bracket future value over present value 1 over n, bracket 1 over n, bracket 1 over n.
Where's the 1 over n staying?
Up at the
Raised to the power. Raised to the power of 1 over n. Yes.
minus 1.
Minus 1. Good. You can choose to cram it if you want to, or you
Exactly.
could deduce it from here if you know how to move your. If you are comfortable with your changes to your formula skills, you could deduce it from here. Now that is sorted. So we were told we're given some basic things here. We want to invest 4 million. What does this represent? You want to invest 4 million.
Present value.
Present value 4 million. So I go PV 4M to get 8 million in the future. That's your future value, right? See it here. What's the N? Mature in 10 years. N 10. Are we clear? So what is our rate of return? What is our interest rate to go by? So you go R equals future value 8, present value 4, raised to power 1 over 10, then minus 1. This all together, 4 divided by, this should give you 2, right? So we just
Yes.
go 2 raised to power 1 over 10, then minus 1. Give me an answer.
So that's
0.
in percent, that's 7.17.
Okay, so let's go with 0.0718 first. Then we now say equals to 7.18%. Are you good, everyone? Who does not understand? Nobody. All right, so that is also example number 5. Somebody help us quickly.
A pension fund manager estimates that his corporate sponsor will make a 10 million naira contribution 5 years from now. The rate of return on planned asset has been estimated at 9% per annum. The pension fund manager wants to calculate the future value of his contribution 15 years from now, which is the date at which the fund will be distributed to retirees. What is that future value?
Now, another concept you need to be very comfortable with when it comes to financial mathematics generally is this: a timeline. Are you clear? So this is now.
That one now.
This could also be expressed as a present value, and this is your future. Are you with me, please?
Yes.
All right, so a pension fund manager estimates that his corporate sponsor will make 10 million contribution 5 years from now. That means by year 5.
Sorry, what did you call this measuring stuff you just did now?
Could you come again, please?
Please, what did you call this thing you just did now?
It's just a timeline. Timeline. Just draw a line.
Okay, is this PV or FV? The one at the left.
Wow.
Left, your left.
Thank you.
Okay.
This is FV, future value. This is PV. Is that clear now?
Yes, thank you.
Okay, so we expect how much? 10 million in 5 years' time. It's not coming now. All right. Now, the question again is what? Rate of return 9%. Calculate what the future value will be in 15 years. No. In 15 years. So if this is 5 years from now, 15 years will be here. All right. Or let me break it down this way. 5, 10, 15. And this is a timeline. Okay. We don't have the money now, but we expect the money to come in 5 years. How much is coming? 10 million. That's what the question gives us. We have the rate of return, the rate of return of 9%. Now, the pension fund manager wants to calculate the future value of this contribution 15 years from now. 15 years from now. Now, there are 2 ways of solving such a question. I hope you have an idea of this now. Or you want to snap this and put by the side because I want to move on to the next page. Are you good to go?
Yeah.
Okay. So what I'm going to do is okay, two methods. Now, I could start from here. Let me draw this again. So I have my number line. Present value, future value, 0, 5, 10, 15. 10 million is coming now. There are 2 ways to solving this question. How do I go about it? I could start from here. Remember the rate is what? 9%, isn't it? So with that at the back of our mind, I could say future value is equal to, what's the present value at this point in time? 10 million.
10 million.
1, 2, 3, 4, 5, 6 into 1.09. I hope you agree with this.
Yes.
Raised to power what?
Raised to power 15.
That's a mistake. Remember, we are starting 5 years from now.
Okay.
So 15 years from now will not be 15 years at this point. It will be 10 years, because from here to here is actually 10 years. Do you get it now?
Yeah.
So because I'm starting at this point, my end will be 10. Because I'm not starting from now. I'm starting from a future date, which is here.
But we are using the present value of 5 years.
We are using the present value at 5 years because the money is coming 5 years from now. We don't have the money now. Are you following?
Or like a lump sum.
We're not even looking at lump sum now, just looking at this particular amount for now.
Okay.
I hope this is clear, please.
Yes.
All right, so let's impute this and tell me what you get. Final answer for your future value.
Mm-mm. 2.10 to trace. That's 23. Wait.
Call it, don't worry. 23,
6736 point.
Another 36 before your
Yes,
point 75. Are we clear on this? Remember, our n is 10. Why? Because we are not starting from now. We moved 5 years into the future. Therefore, that reduces your n to 10 years. Are we clear?
Yes.
Now, there's another method we could have used. We could have chosen to bring this 10 million back into the now. You know, we are not getting it until 5 years from now. So let's find out how much 10 million is now first. Okay, so that will be present value. Of course, you know, is future value into 1 plus r raised to power what? Negative n, or divide by the same principle. All right, so that's 10 million into 1.09 raised to power minus 5. You know, this is year 5, right?
Yeah.
Go. So impute this and tell me what you get.
10 million. 6499313.
6499313.
0.86.
0.86. Now, this is the value of this 10 million now. In 5 years from now, it is 10 million, we know. But for now, it is what? This value you told me now. So this is the present value now. Now, how much will this present value be in 15 years from now? You now take this amount and you now find your future value on it. So future value is this amount, present value, 6499313.86. Then power what? 1.09 raised to power what now? Your n will be what? Remember, you're starting from here. Your n will be what? 15.
Sorry, please. The present value, the one we did, the -5 inverse. How come I'm getting 6.49 raised to power minus 36?
Raised to power, I guess it's your calculator. It's the setting of your calculator. You already got the 6.4999. If you are saying raised to power, is your calculator there? Do you understand? You need to probably, maybe it's in radians or degree or something. I'm not so sure.
But PV is V, FV.
So FV is 23,673,636.7.
The same value, right?
Yes.
Good. So can you see the two ways you can get this done? You could either start from the future time that you're getting the money and adjust your N accordingly from 15 years to 10 years. If you have received the money by 7 years, your N would have been 8 here. That would be 15 minus 7. Okay? Or you first take this and bring it back to the present value. That is what is called discounting. We discounted here, finding the present value. Then we now compounded the present value to get the future value in this number of years. I hope this is clear, please.
Wait, you said something about discounted from where? Like,
so is what we have been doing, just a term, discounting and compounding.
Okay.
So discounting is when you are looking for the present value.
Yeah.
That is what it means. Compounding is when you are looking for the future value.
Yeah.
So when you hear discount, you know you are using the present value formula. When you hear compound, you know you are looking for the future value formula. You are using it.
Question.
Are you clear, please?
Yes. What I'm trying to say is explain what you mean. You say something about moving back to this discount value from 5 from the 5th year. So I want to understand the time that you used what you said. That's it.
I don't understand you.
You were saying something about discount stuff from year 5 down to year 0 before we went.
Okay, I think I do now. So again, you understand what discounting means? That is bringing a future sum to what it's worth now. That's why the arrow comes here. That is the same thing as finding the present value. Then compounding means getting a value now and taking it to what is expected to be in the future. Now that is settled. In line or in the light of the question we considered, I said there are two ways of solving this question. You could either compound the given sum into the future, bearing in mind that your start point is not now, but 5 years from now. And that would affect what your N will be, not 15, but rather 10, because you're not starting at now. I hope that is clear.
Yes.
Or you could first take this 10 that you're expecting it 5 years from now, discount it to now.
Okay.
That is find the present value now. Then when you have gotten it, this sum, you now compound it to the future with 15. It's just times. It's the same thing I've been saying all day.
Okay. Thank you.
I hope it's clear now.
Yes, it is.
Any further questions?
Compounding is the future value. While
Compounding is getting the
present
future value. Discounting is getting the present value. So let's just do some quick drills before we call it a wrap.
Mr. I'm sorry, please, let's not go yet, please, sir. Please.
I'm with you. Go
So
on.
I may choose to use the present year that I am, or I use the next 5 years.
Exactly. Please, Mr. Promise, go on. Ask your question.
Okay, so when you were calculating the present value, the formula you gave us was okay, PV into bracket 1 plus R raised to power n. But that was not what you applied.
Come again, what's the formula I gave you?
PV into bracket.
Let me write that down. Present value.
Okay. Sorry.
PV is what?
So your initial formula is PV equals FV.
FV into bracket 1 plus R raised to power n.
No, it was divided by 1 into bracket 1 plus R raised to power n. That was
this,
the
right?
Yes.
Just turn it to inverse.
Yes.
It's the same thing. So it's the same thing as this into 1 plus r raised to power minus n. Remember I told you earlier that 1 over, let me just say a raised to power minus b, you were told this in SS1, remember, is 1 over a to the power of b. So this is what takes the minus n. So it means all of this can be expressed as future value, this, multiplied by 1 over all of this, 1 plus r raised to power n still. The same thing you have here. FV times 1 will still give you FV over everything down here. I hope it's clear now.
Yes. Thank you.
It's not very clear, right?
No, I understand the inversing.
Okay, Mr. Salako, please, while you were dictating this last question, so I got a different question entirely, and I feel like we never can tell if it might eventually, like something like that can eventually come out of the exam or not, so that people can always have a way of solving it. Because I'm sure we might not really go back to all this simple and compound interest in the class. So the way I got the question was...
Are you saying you got a question or you got a
No.
different answer?
No answer. I will explain it. So when the question was being read, so what I got was the pension blah 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 blah, that the expected future value in 5 years is 10 million, right?
Yes.
So that means we have FV as 10 million, then N, which is the time or duration, 5 years, at 9% per annum, which is the rate, right? Then we were now asked to calculate for the expected future value in 15 years. We already know the future value in 5 years. So, but in 15 years, what could be the future value? And now, in that question, that means we don't even have the present value at all. So that's like 2 questions in one, but it was not, I'm just saying, like, that was how my brain interpreted it. So it was like 2 questions in one, meaning, so the way I did it initially, I looked, so with my first value of future value of 10 million, my year of 5 years, N and the R of 9%, I first calculated for my present value in year 1. Then so after I have my present value, then I now decided to do the N equals to 15, which is what I was looking for. So can such questions come out in a situation whereby they will not give us 2 values, and we have to like do double calculation to actually get the final answer?
What you just narrated seems to me like the second solution we did here. What you just narrated, or am I the only one feeling that way?
Yes, you're correct. It's the same thing.
So what you just narrated seems to me like what we did, the second method we use in solving the question. Again, let's look at why the question is unique. A pension fund manager estimates that his corporate sponsor will make a 10 million contribution 5 years from now. So he's not giving the money now, he's giving it in 5 years. Now, the rate of return we know is 9%. We want to know the future value in 15 years from now.
Sorry, Salako. I don't think we're recording this class.
We are.
He's actually recording.
Are we good?
Yes.
All right. So, in 15 years, how much will this sum be? So that led us to the 2 approaches we used in resolving the question. The first approach was to have a starting point 5 years from now. That means to get a future value, our N would reduce to 10, because our starting point, assuming this were to be our present point now, will be 10 years into the future. That was the first solution we did here. Present value 1.09 raised to power 10. That gave us this value. Now, another way of looking at it was to first discount the 10 million we are expecting in 5 years and bring it back to now. This is the second method. All right, discounting N being a 5 now, because this is sum expected in 5 years. Then we now take this and compound it into the future 15 years. That was the second method that was used here. Madam, I hope that clarifies the question.
It's actually different, but it's all right. I understand your own explanation based on the question.
Oh, okay. Okay, but maybe you look at it again, and then if you can send me a voice note, because maybe later we look at it. It's supposed to be an hour class, and the time is fast spent. So we call it a day for today. And then okay, so here you have the solution. You have the solution. Now quickly, maybe I should just stop the recording first.
No, please, don't stop it yet, please, because I feel like I'm going to pick this class over. So please, just don't
We're done. We're done. What I'm saying is not exactly related to the course content per se, so I can just stop it. Are you good?